Hi friends, my name is Ranjit. We are going to start the topic asymptotic notation in data structure. Uh, Hi friends, my name is Ranjit. Asymptotic asymptotic notation. First is there are three types of. One is big O notation. Second, omega. Third, theta. So these are the three types of notations: big O, omega and theta, and we will explain each one by one. First we take big O. Big O notation. So big O notation have some for like some conditions like function n equals to big O of gn if and only if and only if condition like fn less than equals to c dot gn, where for all n n greater than equals to n naught, these are the constants, right? Constants है ना, and so c, these are the constant, c must be greater than 0 and n naught greater than equals to 1. So this condition should be satisfied: c always greater than 0 and n not greater than equals to 1. So this is the conditions: fn less than equals to c dot gn. This condition should be satisfied, then it is big O notation, right? Condition should be satisfied. Now take one example. Fn n square plus n plus 10 gn n square. So this is fn and this is gn. Fn condition should be satisfied, big O of gn. So what is the value of fn? n square n square n square plus n plus 10. condition less than equals to c dot what the value of gn, n square. So this is fn, this is fn, and this is gn, this is c, constant, and condition should be satisfied, like for all n, for all n greater than equals to n naught. So if we put n naught value 3 and c value 3, so it would be 3 square plus 3 plus 10, 9 plus 3 12 plus 10, that it would 3 square plus 3 plus 10, it would be 3 dot 3 square. So it would be, we are writing here 3 square plus 3 9 plus 3 12 plus 10 27, sorry 3 3 9 3 12 plus 10 22, less than equals to 3 3 9 3 cube, so it will 27. So this condition is satisfied, fn less than c dot gn. So this condition is satisfied. That's why it is the n big O n square plus n plus 10 big O n square. So this condition is satisfied. So this is the big, it follows the big O notation, f and g n. Now we take another example of big O. Condition we mention here, fn less than c dot gn, and for all n greater than equals to n naught, and c greater than 0, and n naught greater than equals to 1, right? So this is big O. Now we take another example, fn n gn n plus 10. So for the big O we have to prove the condition fn less than equals c dot gn. So what is the value of n less than c dot gn? What is the value of gn? N plus 10. So we have to satisfy the conditions. So if we put the value of for all n greater than n naught, if we put the value of n naught 1, and what the value of c 1, so n 1 dot n plus 10, and we also put the value of n given when, so it would be a 10. So it satisfies the above condition. It satisfies the condition fn less than equals to c dot gn. So it follows the big O notation, n big O n plus 10. It follows the big O notation. Now we take another example. We mention the condition fn less than equals to c dot gn for all n greater n naught, c greater than 0 and n naught greater than equals to 1. So this is the big O condition, big O. Now example fn n square gn n. We have to prove the condition fn less than equals to c dot gn. What is the value of n? N square. What is the value of gn? N. And we have to prove for all n naught, right? So we can see that the power of n is 2. Here the power of n is 1. So it always be greater fn. So we cannot prove the condition, that condition, right? So we cannot make it the greater, this side, right side. We cannot make the right RHS side greater because this it is having a n square. That's why it doesn't follow the big O notation, and the answer would be n square, not follow or big O notation. So it doesn't follow the big O notation because it doesn't follow the condition. Now we see the another example. Condition we first mentioned, c dot gn for all n greater than equals to n naught or n naught greater than equals to 1, c greater than equals to 0. Example f n plus 10 gn n minus 10. We have to prove the condition fn less than c dot gn for big O notation, right? So what is the value of fn? N plus 10. What is the value of gn? N minus 10. So it for all n greater than equals to n naught. If we put the value of n naught 30 and value of c we put 2, so it would be greater, right? So this side RHS side would be greater. You can calculate also. 3 plus 10 40, 30 plus 10 40 less than 2 into, right? So it would be equal. So it satisfies the condition for big O notation. Hence n plus 10 follows big O notation. It follows the big O notation. Now next we see the omega notation. Omega notation. First we will see the condition fn equals to omega gn, if and only if fn greater than equals to c dot gn for all n greater than equals to n naught, and n or c both are constant, c always greater than 0, n naught greater than equals to 1. So this is the condition for omega notation. Take one example. Fn equals to n gn n plus 10, and we have to prove the condition fn greater than equals to c dot gn. And what the value of fn? N greater than equals to c dot gn n plus 10 for all n greater than n naught. We put the value of n naught 10 and put the value of c 1 by 2, so it will prove the condition. This condition you can calculate. So hence n omega n plus 10. Now see next example. We write the condition of omega notation fn fn greater than equals to c dot gn, and for all of n greater than equals to n naught and c greater than 0 and n naught greater than equals to 1 for omega notation. Now take the example fn n square plus n plus 10 gn n square. We have to prove the condition fn greater than equals to c dot gn. Put the value fn n square plus n plus 10 greater than equals to c dot n square for all n greater than equals to n naught, and put the value of n naught 1 or put the value of c 1. You can calculate, it would be greater 1 plus 1 10 12. Now it would be greater, hence it is a omega notation. This condition follows the omega notation. N square plus n plus 10 omega n square. This so it follows the omega condition. Now next take jumble omega notation condition. We mention fn greater than equals to c dot gn. Example fn equals to n gn n square, and we have to prove the condition fn greater than equals to c dot gn. Fn, what the value Fn n greater than c dot gn n square. So we can see the power of n is square, here the power of 1, so it would always be greater, so we cannot prove the condition Fn greater than equals to cjn. So that's why n not is the omega, so this doesn't follow the omega condition, right? It's not a omega. So it doesn't follow the omega condition, right? Now next move to the theta notation. Theta notation. The condition for theta notation, Fn equals to theta of gn. First we have to prove it should be big omega notation. Fn c1 dot gn for all n greater than equals to n naught, and दूसरी second condition, Fn greater than equals to c2 dot gn. It should also follow for all n greater than equals to n naught. So there are three constants, c1 greater than 0, c2 greater than 0, and n naught greater than equals to 1. So this is the condition for theta notation. Now take example. Fn n gn n plus 10. First prove the condition of Fn greater than equals to c dot gn for omega. Fn n greater than c dot gn n plus 10 for all n greater than equals to n naught. We put the value of n naught 1, and we put the n naught value of 10, and put the c value of c 1 by 2. It will follow the condition of omega notation, right? So it follow the condition of omega notation, and for big O it should also follow the big O notation condition. Fn less than equals to c dot gn, Fn n less than equals to c dot gn n plus 10 for all n greater than equals to n naught. Put the value of n naught 1 and put the value of c 1. So it would be, it will also follow this condition, right? That's why n equals to theta, so it follow the theta notation, and theta n plus 10, so it follows the condition of theta. Value of c1 1, c2, this is you can say c1, this is you can say c2 1 by 2, and n naught 10. Now take another example. Fn n square plus n plus 10 gn n square. First we have to prove omega condition. Omega condition fn less than equals to c c1 dot gn fn n square plus n plus 10 c1 dot gn n square for all n greater than equals to n naught. Put the value of n naught 4 and put the c1 value 2, and it satisfy the condition. You can check it will satisfy the condition. And for omega, for omega fn greater than equals to c2 dot c2 dot gn n square plus n plus 10 greater than c2 dot gn n square for all n greater than equals to n naught. Value of n naught 1 and value of c2 1. So it will also follow the condition. So we can say that n square plus n plus 10 theta n square. So it follows the theta n square condition. C1 2 C2 1 and not 4. We take another example. Fn n gn n for omega. First can prove the for omega big O notation condition. Fn less than equals to c1 dot gn n less than c1 dot gn n. Yes, it follow the condition for big O and for omega fn greater than equals to c2 dot gn 1 n greater than equals to c2 dot gn n. Is if we put the value of you can say for here also for n naught, put the value of n naught 1 and n1 c1 value 1. It follows the for here also for n greater than equals to n naught, put the value of 1 and put the value c2 1. So it follows the condition. That's why n equals to theta n equals to theta n c1 1 c2 1 and not 1. Now we take another example. Fn n square gn nq. First we check for big O. Fn less than equals to c1 dot gn. So what the value of fn n square less than equals to c1 dot gn nq for all n greater than equals to n naught. Put the value of n naught 1 and put the value of c1 1, right? So it follows the big O condition. And for check the omega condition, fn omega can we check the for omega, right? If we check omega fn we check fn greater than equals to c2 dot gn fn n square c2 dot gn is n cube. This power is greater than this power, so it always be greater RHS side. So B cannot prove that LHS would be greater. That's why it doesn't follow the condition of omega. That's why it is not the theta notation. That's why n square not the theta notation. Right? So these are all the concept from notations: theta, big and small, theta, omega, and big O notations. And now we will see one more topic: complexity classes. First is constant complexity. First is constant. We take order of 1. And for logarithmic complexity we take order of log n. And for linear complexity we take order of n. For quadratic complexity we take order of n square. And for cubic complexity we take order of n cube. For polynomial complexity we take order of n to the power c, where c is a constant and c greater than 0. Now fifth, exponential complexity. Exponential complexity, order of order of c to the power n, or c greater than 1. C is a constant. Now we can see next is 2 की power n less than n to the power n, 2 की power n greater than n raised to the power log n, n always greater than log n, or n factorial less than ever n, 2 raised to the power n less than 3 raised to the power n. Right? So these are some complexity classes, right? And thank you for the guys.